Hello everyone, what's up people? How is everyone doing? I hope that all of you guys are doing good during this quarantine time. I know you guys are bored out of your mind, but still, that's the way it's supposed to be. Stay safe guys, stay home and stay safe. Welcome to today's session nonetheless. This is going to be session number 5 of Refraction of Light at Plane Surfaces, which means that we've already done 4 sessions of this chapter, and if you haven't watched all those videos yet, please do watch all those videos so that you get an idea of what we're doing and you get the whole picture, not like just that first half or the second half of that picture, but the entire picture as a whole. My name is Anoop and this is Vedantu's 9th and 10th channel, or the medium of speaking is apparently English. So welcome to today's session nonetheless. So guys, what are we going to talk about in today's session is basically the what exactly is real depth and apparent depth. Now this is a very important concept. Before we get started, let me just tell you one quick thing that I moved to a new place. That's why the background and the lighting is pretty bad. I'm really sorry about it, but hopefully by in the next 2 days it'll be all fixed and we'll be back to normal. So with that said guys, let us get started with today's session. But as always, there's a quote waiting for you guys. This is the quote for today: one's best success comes from their greatest disappointment. And this was said by Henry Ward. No matter what the field that you're in, no matter what you're trying to achieve, you have to fail. You have to feel that disappointment to actually get to where you want to. And if you don't feel that disappointment, if you don't face those failures, then you can't taste the actual victory as well. So this one's for all of you guys out there who are second guessing your thoughts, who are trying your best and still coming up short. Do not give up. You can still make it through. You just have to get through that phase, and there's always light at the end of the tunnel. Just remember that. All right. Anyways, with that said, let us get started with today's session, which is nothing but real and apparent depth. But before we get into the actual topic, guys, I had given you a silly little homework in the last session. Not silly, but yeah, it's a simple little homework. The question was this: how does the angle of deviation depend on the refracting angle of the prism? So this was the question. How does the angle of deviation depend on the angle of prism? Is what kind of relationship do they have? Is it like Karan Arjun wala relationship, or is it something else like altogether? So that was a question. But nonetheless guys, the answer to this question is that they are directly proportional, in the sense if the angle of prism increases, then the angle of deviation would also increase. It's a direct relationship. So if this increases, this increases. If this decreases, that is the angle of prism decreases, then the angle of deviation would also decrease. So that's the first question, people. With that said, let us get started with real and apparent depth. Now, for you to really understand this topic, let's take a very simple example. You could actually try this experiment at home, and it's a wonderful little experiment. I know it might sound silly, but then it's actually a pretty cool experiment. Alright, here's what you have to do: take a bowl, place a coin inside it, right? And then pour some water into it. Now, what you notice is that you can't see the coin at first, but as you pour the water into the bowl, you see that suddenly, magically, you're able to see the coin. How does that happen? What is the possible explanation for this? Is it that the water is magical? Is it the coin magical? Is coin is magical, or the bowl is magical? What exactly could it be? The answer, guys, is refraction. It's a very simple concept. We've studied this already. What is refraction? The bending of ray of light when it's traveling from one medium to the other. So when two rays of light are coming out from the coin, once it reaches the surface of separation, what happens? The surface of separation between air and water, there's refraction happening, the bending of light happens, and what happens? It reaches your air after it bends, and it reaches your air, your eyes. Now, here's the thing: our eyes do not actually know where the object is. Our eyes is basically, I don't know, is not smart enough. All right, that's the way I would like to put it. Anyways, so our eyes are not smart enough to actually understand where the coin is. So what does our eye do? Our eye wants to find out what is the source. He wants to find where the culprit is. So what does he do? Our eyes will try to trace back that steps from where the light appears to be coming from. Right? So what happens is that to our eye, the object seems to be raised. To our eyes, the image, when it's trying to trace back the steps, the image is formed at a distance which looks a little raised up from the original coin. Now this is what is called as the apparent depth of the object. So this distance from the surface to this point is called as the apparent depth, because that is apparently where the coin appears to be, and this here is the real depth of the coin, because the coin is actually there, it's actually really there. So that height is what is called as your real depth and the apparent depth where the image appears to be. Now this difference in height between the real depth and the apparent depth is called as shift. This is called a shift. Now what's the formula to find out shift? You might be wondering that. The formula to find out shift is, guys, it's real depth minus the apparent depth. Simple. Real depth minus the apparent depth gives you what is the shift. So whatever is that difference in that height, that you can find out by using this simple formula, that is real depth minus apparent depth. Done, done, done. Simple. Alright. Now that you've understood this case, let's move ahead and understand how do we prove that real depth, apparent depth, and refractive index of a medium is actually related. So like I told you, this is the apparent depth, this is the real depth. Now remember these terms, because I'll be asking this as we go ahead as well. When we're doing the proof as well, we'll be doing this. So remember these terms very, very carefully. So to define what is real depth and apparent depth before we get into the proof, real depth is the actual distance of the object beneath the surface of separation. Apparent depth is where the image appears to be. So when a medium when the medium is in the depth of an object, in the medium of is the depth of the object. In a denser medium, as seen from the rarer medium, the value is going to be smaller for this one. So let me just keep it simple rather than making it all complicated. What is the apparent depth? Is nothing but where the image appears to be, So when you're seeing an object from the rarer medium to the denser medium, where is the height of the image appearing to be, that is called as the apparent depth. And generally, for when you're looking at the object from rarer to denser medium, the image appears to be a little raised up, which means that the apparent depth is going to be less than that of the real depth. So the value of apparent depth is going to be less than that of real depth when you're looking at the object from rarer to the denser medium. That's what this statement says, which I could not even read properly. Anyways, with that said, guys, let us now look into something. Like I told you, how is real depth, apparent depth, and refractive index related? Here's the formula, guys. Refractive index of a medium is equal to the real depth divided by the apparent depth, or real depth upon apparent depth. That is what is refractive index, or you can define refractive index as real depth by apparent depth. Now to actually prove this, let's assume a simple coin. Right? So let's say that there's a coin that is kept inside water or glass, and you're looking at the object from the air. So what happens? There's one ray of light that is passing through straight at the surface of separation, gets refracted, and as it's going from denser to rarer medium, it goes away from the normal, and so what happens? It reaches your eye. Now, for your eye, the ray of light is actually coming from here. For your eye only, right? For your eyes only, the image or the object appears to be coming or is placed over there. So this then becomes the apparent depth of the object. This is where the coin appears to be, and this is where the coin actually is. So I'm going to name all these, all right? So I'll call I'll also draw a normal to this surface. So normal is n dash, and there's one more ray of light that is passing through straight through that surface of separation. So when it's traveling, when the ray of light is incidenting exactly at 90 degrees to the surface, then the angle of refraction would also be 90 degrees to the surface itself. So it passes through undeviated through the normal itself, will pass through it. So here we have that is O A dash. All right. So this is what is represented as O, A, and A dash. O is the origin, A dash would be the refracted ray, or of that particular ray of light, which is coinciding at 90 degrees. All right, now this point I'll call it as B. This is A. This is I. That is where the image is apparently present, and this here I'll call it as C. So I'll call that ray of light as C. Simple. A very simple diagram, nothing to worry about. So the surface of separation, will call it as P and Q. You can name it whatever you want. There's no nomenclature for it. You can name it whatever you want. This is just for your own convenience that they've put it like that. That's all. Don't worry too much about it. Don't by heart this. It's important that you understand that. All right. Now, this here would be the incident ray. This is the angle of incidence, because it's going or you can call this as the angle of incidence because it is going and hitting the surface, or it's incidenting on that surface of separation, that is PQ, that is I. And this here would be the angle of refraction, because why? Because it's getting refracted. The ray of light is bending away from it, so that will be the refracted ray. Awesome. And that R would be the angle of refraction. Now, let's prove it. Here's what I want you guys to understand. I want you guys to think about all the math, geometric related, especially the parallel lines related theorems and proofs that you've studied in your past. First thing, this is incident, this is angle of incidence, this is the angle of refraction. Awesome. Now, assuming that, you don't have to assume it, it's actually true. OA dash, this line, and this line, aren't they parallel to each other? Look at it for a second. Absolutely no doubt about it. OAA dash and NN dash is parallel to each other. So these both are parallel to each other. Can I call this line as the transverse, which is cutting both these parallel lines? That's a transverse line. Simple. Alright, now I'm going to erase this part out. Hold on guys, I think I messed it up. No, yeah, everything's fine. So as I was saying, sorry about that. Yeah, that is the angle of refraction. That is the angle of incidence. Sorry, that is the transverse line. Now, what I'm going to do, I'm just going to erase this part out. Okay, sorry about it guys. So, trying to figure it out. Alright, yes, here we go. Alright, now, so far I hope that you guys are clear with it. Now, if this is the transverse line, and this is the angle of incidence, this is the angle of incidence. If that is the angle of incidence, can I say that this angle is also equal to this angle? How? Alternate interior angle wala formula, or alternate interior of a transverse line, which are parallel to each other. Alternate interior angle says that the angle is going to be equal. From that proof, we can say that this angle here is equal to this angle. Very simple. Alternate interior angle. All right. Now what I'm going to do, I am going to erase this part out and assume the dotted lines to be the transverse now. Now this is my transverse, because that is also cutting the two parallel lines, so that is the transverse now. In this case, if this is angle of refraction, can I say that this is also angle of refraction? That is also how? Corresponding angle. Simple. So that is R, this is also R. Very simple. This is I, this is I. That is also R, this is also R. Awesome. Now what I'm going to do is that I'm going to use the second law of refraction. What does the second law of refraction say? Sine of angle I to sine of angle R is a constant, which we saw is nothing but the refractive index. So refractive index is equal to sine I by sine R. Now, for this triangle, for the first triangle, that is triangle OAB. For triangle OAB, I am going to use, or I'm going to find out the sine of that angle. So here I'm going to take, this is the angle I. So what is sine I over here? For triangle AOB, what is sine I? Sine I is what? Opposite by hypotenuse. What is the opposite? Opposite is AB. What is the hypotenuse? Hypotenuse is OB. So I'll get as AB minus AB by OB. Now for the same thing, I'm going to do it for the second triangle now, which is nothing but this triangle, which is which triangle? This triangle, that is AIB. Exact same thing, but this time I'm going to find out the sine R value. So for triangle AIB, what are you going to get? So sine R is equal to opposite by hypotenuse again. Opposite is AB and hypotenuse is IB. Simple. So far so good. Now what I'm going to do? You know the next step. I'm going to substitute the value of sine I and sine R in this equation. So what will I get? Mu is equal to sine I is what? AB by OB, and sine R is AB by IB. Simple. AB gets cancelled. So what are you left with? Mu is equal to IB by OB. Simple. So I found out that the refractive index is IB by OB. Now this is the refractive index of air with respect to water. All this while what I was talking about is the refractive index of air with respect to water. I forgot to mention that, but yeah, it is the refractive index of air with respect to water. But I don't need to find the refractive index of air. I don't even consider the refractive index of air because my eyes is also in the same medium, so it does not refract at all. What I'm bothered about is refractive index of water or the glass or whatever the denser medium is. I'm going to assume it as water for now, right? So what is the refractive index of water? How will you find that out from this one? The refractive index of water would be equal to the reciprocation or reciprocal of this, which is nothing but OB by IB. Simple. So far so good. OB by IB, just the reciprocal of that, or reciprocating the value of that, you would get what is the refractive index of water with respect to air. So far, awesome. Now, here's the thing, guys. In real world or in actuality, this AB distance that you have right now is actually very negligible. It's actually very, very negligible. It's a very small distance. So what I'm going to assume that is, I'm going to assume that B, which is like this right now, is going to come close and become a straight line now, because it's very close. So I'm just going to assume, because the distance is negligible, I'll put both of them on the same point. So what I have right now is basically this point. Suddenly now I'm going to whatever the new assumption is, I'm going to represent with a different color. So I'm going to assume this as AB right now. All right, that point is AB. If this point is AB now, let's try to find out what is the change in the values now. So if AB or that point A and B has now become AB, this distance then becomes what? This distance becomes what? OA. I can write it as OA. So the refractive index of water with respect to air, I can write it as OA. And what is this distance now? This distance I can write it as IA. Very simple. Now, from the diagram, what is OA and IA? Now, this is after assuming that B and A is equal. There's no difference between B and A because the value of them, or the the distance between them is negligible. That's when I get this assumption. All right, that's when I get this. So in that case, what is OA and what is IA? Look at the diagram, guys. Think about it for a second. Just tell me. OA is what? The real depth of the object. What is IA? The apparent depth of the object. So can I say that refractive index of water with respect to air, or the refractive index of medium with respect to the air, is equal to the real depth by the apparent depth? Absolutely. So that's how, my friends, we prove that refractive index of medium is equal to the real depth of the object divided by the apparent depth of the object. Very simple, isn't it? That's all, guys. But yes, you can get confused here and there. So it's very important that you practice. You don't just sit and listen and then believe that you're done. No, your work is not done yet. You have to revise. So make sure that you revise. Make sure that you practice it, and let me know in the comment section if it actually was easy for you to understand or not as well. So that, my friends, is how you find out, or how you prove that refractive index of medium is equal to the real depth divided by the apparent depth. Simple. All right. Now that you understood this case, let's take a look at an everyday example. So let's say that you put a pencil inside the water. You see, there's a pencil apparently, looks like it's bent, but is it actually bent? No, it is not. It appears to be bent. Why does it happen? Because of refraction again. So what happens? This is the actual depth of the pencil. AB is the actual depth of the pencil, but because of refraction, it appears to be a BA dash. That is where it appears to be to our eyes. That is where it appears to be. And this is something that you have to understand, that when an object is immersed in a different in a liquid, or in a liquid with a different density, there is some sort of refraction happening, and because that it appears to bend, or it appears like it's rised up a little, and that is what the real depth and apparent depth is all about. Now, in the past, before, when we started the session, I told you a simple formula, that is shift. What is shift? Shift is nothing but the real depth minus apparent depth. Now I am going to show you an advanced formula of shift, from which you can find out, if in case let's say the real depth and apparent depth is not given, you can still be able to find out, you'll still be able to find out the values of the shift using that particular formula, which I'll be telling in a minute. Before we get into that, here's the thing. It's not just that when you're looking at the object from rarer to denser medium that there is this there is the shift happening. When the object is viewed from the denser medium to rarer medium, also it appears a little higher, or it appears to be raised up. So this is where the object appears to be, and this is the actual height of the object. Again, how do we come to that conclusion? Again, because of the fact that there is a refraction happening. So this is how the ray of light was supposed to go, but then because of refraction it went this way. So it again looks raised up. So when the object is viewed from denser to rarer medium, also it looks raised up. When the object is viewed from denser to rarer medium, also it actually looks raised up. So it's because again, principle of reversibility. I told you this. Light rays would, even if I were to trace back the path, it always takes the same path. It will not change the path. So here also it is the exact same scenario. So here also it appears to be like that itself. So here you see this, when the person is viewing, the person is swimming underwater, it appears the object, the person is actually over here, and for him, for that person who's viewing from the outside, it appears like the person is over there. And when the person is from here, when he's looking at this person, it appears like the person is over here. Again, it looks raised up. So that is what I had to tell you, people. Now with that said, guys, let me just tell you that advanced formula that I told you before. Shift is equal to real depth by minus apparent depth. But what is real depth or what is apparent depth? I can either use either of these. Now I saw that we have already seen that mu is equal to, that is the refractive index of water with respect to air, is equal to real depth by apparent depth. Now what is apparent depth? Apparent depth is equal to real depth divided by mu. Now what I can do is I can substitute this value in place of the the apparent depth. So what I'll get, shift is equal to real depth minus real depth divided by mu. So I can take real depth common, so I'll get it as 1 minus 1 by mu. So if I have either one of the values, if I have the real depth itself, I'll be able to find out what is the shift without even having to have both the values, that is the real depth and the apparent depth. If I have real depth alone and the refractive index of the medium, I would still be able to find out what is the shift. It's a very simple formula. Again, this is basically bottoms up approach. You've already found that out. You're substituting the values over there to find out what are the alternative formulas to find out the same. Very simple, guys. With that said, now let me talk about what are the factors affecting shift. Obviously, there are certain factors that it depends on. It's not like shift is common for every medium. Like for example, the shift in water might be different from that of honey. From honey, it might be different than that of blood. So everywhere, because the densities are different, because of certain the refractive index of the medium, there are a lot of factors that it depends on. First is the refractive index of the medium. More is the refractive index, the greater would be the shift, because the light then would refract more. We have seen that already. The light would refract more if the refractive index is more, and so the shift is also greater. The second point that affects shifting is the shift is nothing but the thickness of the denser medium. If the density of the medium is more, then the shift is also going to be more, because obviously the ray of light would bend more. It slows down even further, which means that the ray of light would bend even further. So it also depends on the thickness of the material as well. And finally, but definitely not the least, the dependence on the wavelength of light as well. The greater the wavelength, the lesser the refractive index, so the lesser would be the shift as well. So shift decreases with the increase in wavelength, which means that red light will have the least shift, whereas violet light will have the greatest or the highest shift, because it refracts the most. I hope you guys understand this. With that said, guys, let us solve some questions. But before we get into the questions, I have an important notice to not notice, an important information to give out to you people. Now this information can be very, very helpful to all of you guys out there. So this is what is the thing, guys. We had actually taken up a survey asking you guys what are the problems that you guys are facing, especially during this quarantine time where you don't get to go to school and get your doubts cleared and stuff like that. So what exactly are you guys facing on a daily basis? So these are the things that you guys came up with. It's not something that we made up. These are the things that you guys had told us. Now I'm pretty sure that you'd be able to relate to all of these, but yeah, there would be thousands more, but these are some of the things that we thought would definitely be addressed to the larger majority. The first one, doubts, right? Because you don't have your teachers to go ask your doubts, so it's going to be a very big problem. Your the smart friends are at home and your teachers are at school. They're also at home, so there's no way for you to get your doubts clear. That's a very big problem. Secondly, your notes, because you're studying from so many different YouTube channels and websites and stuff, but you do, very rarely that do you get all the notes, and the notes that you get is only about 98%, and I'm pretty sure that everyone wants to be 100% prepared for your exam. So that is also a big problem that you guys are facing. Thirdly, tests and assignments, because yes, you want to practice as many questions as you possibly can before you walk into your exam hall. You just don't want to go and sit there in the exam hall and wonder what the step is, what is the next step. So you want to practice those questions as well. Fourth, competitive exams, because I'm pretty sure that you guys are planning to give your Olympiads and KUPY and so many different exams, competitive exams out there, and you guys have been waiting for it for a long time now. So how do you prepare yourself for that? Fifth, choice of your own schedule, because yes, classes happen whenever the teacher wants it or whenever the organization wants it, not when you want it. So how do you come across that problem? And finally, people, definitely not the least, it's nothing but choice of your own language as well, because that is also a very big problem in India. We have so many different language speaking states, so it's impossible for us to teach all the concepts in regional languages. But yes, the choice of your own language is also a very big problem. Here's the thing is, we at Vedantu are proud to say that we have found a solution for all of your problems, starting with the doubts. Inside the session, you will not just have one teacher, you will have two teachers. You will have the master teacher to help you clear your conceptual doubts, to help you make you understand the concepts and stuff. But apart from that, you'll also have the class teacher who will help you clear your doubts as well. So you get personalized attention, making sure that your doubts are cleared inside the class and you're not walking out of the class with any doubts in your mind. Secondly, you can download all the notes and watch the recordings how many ever number of times you want. There's no limit to it. You can watch the recordings 10, 20, 30 times, download the notes 100, 200 times, totally up to you. I know it's not needed, but still, if you want to, you can go for it. Thirdly, you'll have regular tests and assignments, and based on these tests and assignments, you'll also get a personalized report card as well, which tells you where you're going wrong, what are the things that you have to do better, and what are the strengths of your concept, what are your strengths and everything, weaknesses, everything would be given to you as well. You will also be trained for your competitive exams, whatever competitive exams you're planning to give, you will be trained for that as well. You can choose your own schedule. Now that is a very important thing. You have live classes going on pretty much every time of the day. You can choose your own time and choose a particular teacher that you want to and study with that teacher. There's no compulsion that you have to attend the class exactly at 4 o'clock. If you feel like studying at 7, you can go ahead and study with that teacher at 7 as well. There's no compulsion at all. And finally, guys, you can choose your own language. That is, your classes are offered in both English as well as in Hindi. So whichever language you feel is more comfortable. If you're someone who understands Hindi better, then you can choose the Hindi medium, or in the sense everything is the same, just that the medium of communication would be in Hindi. And if you are someone who's comfortable with English, then you can choose that as well. Depending on whatever is your comfortability, you can go with that as well. And apart from these guys, that's not it. You also have unlimited live classes, all micro courses and crash courses, performance report card like I told you, and personalized attention, making sure that your doubts are clear. So what you're supposed to do is very simple, guys. The link would be given down in the description. Click on that link that is given in the description. As soon as you click on the description, this is what you're going to get. They'll be asking you which grade do you belong to. So let's say that you're in 10th grade. Click on the 10th grade and they'll ask you which board do you belong to. Do you belong to CBSE, ICSE, or Maharashtra board? At this point in time, we are offering classes for these three boards: ICSE, CBSE, and Maharashtra. In the future, we might be adding IGCSE and what or what not, or the other your syllabus as well. Let's say that you are in ICSE or CBSE. Click on ICSE or CBSE. Once you click on it, this is what you're going to get. Every detail that I just told you in one glance. You can pause the video and read it if you want to. Then what you have to do is basically click on get subscription. Once you click on get subscription, this is what you're going to get: 1, 3, or 6 months. So let's say that you want to try for the next 30 days and see how it goes. So if you go for the 1 month program, the base price of that is 4,000 rupees. But do not worry, guys, we've got you covered, because I know that 4,000 is a big amount. You get a primary discount on that. You get to pay around 2,699 rupees, which again is a big amount. But do not worry, again, if you want to save more money, enter the coupon code AMPRO and get additional 539 rupees discount. And what you'll be paying is 2,159 rupees for the whole month. Let's say you want to go for the 3-month course. This 3-month course, the base price of that is 10,000 rupees. I know 10,000 is a big amount, but don't worry guys, we've got you covered. You'll get out, you get a 3,000 rupees discount. Essentially what you'll be paying is 6,999 rupees. On top of that, if you want to save more money, enter the coupon code AMPRO, get additional 1,399 rupees discount, and what you're gonna get is basically 5,599 rupees. Let's say you want to go for the 6-month course. For the 6-month course, the base price is 16,000 rupees. It's a very big amount. But again, guys, you get a primary discount on that. 11,499 rupees is what you're going to pay. But if you want to save more money, enter the coupon code AMPRO, get additional 2,299 rupees discount. And what you'll be paying essentially is 9,199 rupees for the next 6 months. I know it seems like a big amount, but think about it, guys. You'll be studying with the best of the best teachers, with all of the best, live interactive classes, with class teachers, everything to make sure that you guys are walking out with the best experience. So do check out the links. It'll be given down in the description, and also do not forget the coupon code AMPRO. That's it from my side, people. With that said, let's now solve some questions and try to understand if we have truly understood the concepts or not, right? So here's the first question on your screens right now. The apparent depth of the fluid in a vessel is 15 centimeters when its real depth is 20 centimeters. Find the refractive index of the medium or the fluid. Is it 1.25? Is it 1.33? Is it 0.75 or 0.25? What do you think is the right answer? Let me know in the comment section below. The answer to this question is pretty simple, guys. Real depth is given as 20 centimeter. The apparent depth is given as 15 centimeter. The refractive index of a medium is basically real depth by apparent depth. What is the real depth? That is 20 centimeters, and the apparent depth is 15. So 5, 3, 15, 5, 4, 20, 3, 1, 3. So it will be 1.33. 3333 would be the right answer for this question. So the refractive index of the medium is 1.33. Simple, and refractive index does not have any unit, so you can ignore that as well. Well done. Second question, here's another one. A coin kept under water with refractive index of 4/3 when viewed from the air in a vertical direction appears to be raised by 2 mm. Find the depth of the coin. You're supposed to find out what is the real depth of the coin. See guys, they've given you that it appears to be raised by 2 mm. So you don't know what is the actual depth. This is basically the shift. They've given you what is the value of shift. So let me make that clear, guys. This is actually the shift. It is not the apparent depth. They're giving you the shift, which is 2 mm. They've told you that it appears to be raised by 2 mm. By what? Is it 5 mm first and then 2 mm, 7 mm first, then 2 mm? You do not know that. So you're supposed to find out what is that real depth value. They've given you what is the refractive index of water as well. That is 4/3. Okay, here's the thing, guys. I'm going to assume the real depth to be x. All right, real depth I'm going to assume it as x. So if you substitute, like we know that refractive index is equal to real depth by apparent depth. Awesome. The refractive index is given by 4/3, and the real depth is x. So what would be the apparent depth? Apparent depth is equal to what? It'll be 3x by 4, right? 3x by 4, that's what you're gonna get. Cross multiplication, it gets 3x by 4. Now what I'm gonna do is that I know that shift is equal to real depth minus apparent depth. Real depth is given as x, and apparent depth is 3x minus 4. I'm going to substitute this value over here. All right. We know the formula of refractive shift is nothing but real depth minus apparent depth. And we have already seen that the refractive index of a medium is real depth by apparent depth again. So I'm going to substitute that value over here. So what I'm going to get, I'm going to simplify this equation. I'll get it as 4x minus 3x divided by 4, which is nothing but x by 4. So I got shift is x by 4. What is the value of shift? It's 2 mm. So I can put that over here. So what is the value of x? X is equal to 4 into 2, which is nothing but 8 mm. Simple. So the real depth of that particular coin is 8 mm. Simple, guys. This is the steps. If you want, you can take a screenshot of this also. With that said, guys, moving on to the third and the final question for the day. A water pond appears to be 2.7 meters deep. If the refractive index of water is 4/3, find the actual depth of the pond. They've given you the apparent depth. They've given you the refractive index. Find out the actual depth. Very simple question. Is it 1.4 meter, 3.6 meters, 2.5 meters, or 1.5 meters? Let me know what is the answer, guys. So let me just put it down. So for the first one, the apparent depth is given as 2.7 meters. They've given you what is the refractive index as 4/3. So what is the formula? Mu is equal to, not m, mu is equal to real depth by apparent depth. Real depth is I do not know. I'll just keep it as okay. I'll just keep it as RD itself. Apparent depth is given as 2.7, and this is 4 by 3. So real depth is equal to 4 by 3 into 2.7. So 3 927. So that's 0.9. 4 into 3 0.9 is it's 4936. So it'll be 3.6 meters. Simple. That's how it is. That is the answer for this question, and by that we have completed the topic for today as well. So this, I know this by this we'll be completing the topic for today. We have one homework question as well, guys. So the homework question for today is basically this one: shift shift dash with increase in the wavelength of light use. Let me know what is the answer in the comment section below. Shift dash with the increase in the wavelength of light use. Let me know what is the answer for this in the comment section below, guys. That is it from my side. I hope you guys enjoyed today's session. Leave a like, subscribe to the channel, do everything that is needed. Click on the bell icon as well. Thank you for joining. If you want to talk to me or reach out to me personally, you can reach out to me at anoop.manon@vedantu.com. And once again, sorry for the background, sorry for the lighting, guys. Everything is being set up. Don't worry, by the next session everything will be back to normal. Thank you for joining. See you guys in the next one. Take care of yourself. Peace out, people. Bye bye.